quadratic equations for this week, and the standard form for those is ax squared plus bx plus c. We're going to be setting it equal to 0 tonight. So that's the difference in what we did. The last test was just factoring. This one is going to be actually solving. We're going to get x equals a number type answers with this. So I'm going to talk about the different ways of solving. There's several different ways that we can do that. What makes it quadratic is that x squared is the largest exponent. Okay, so x squared is our term with the largest. So we'll, as we progress through this material, we'll get to larger ones, but x squared is what we're going to be dealing with tonight, doing all the quadratic stuff tonight. So one of the ways to solve quadratic equations is by factoring. Yes, ma'am. Yes, ma'am. Solve by factoring. And this factoring is the same factoring that we used in last 2 weeks, okay? We're employing what's called the zero product property. And what that property says is fairly powerful, but not necessarily very interesting to read, so we won't write it out. But what it says is if you have two factors that multiply together to get 0, then at least one of them is 0. It could be both of them. We're going to take the worst case scenario and say it's both of them, okay? What I'm talking about is if you've got a problem with two factors, each parenthesis is a factor, x plus 7 and x minus 5, and those two factors multiply together to be 0, then at least one of them is 0. We're going to take the scenario, both of them are 0. So you set each factor equal to 0. And then you solve them individually. So here we'll subtract 7. So x equals -7. That's one of our answers. We would add 5 on this side. The x equals 5. There's our second answer. And we get 2 answers for these. Sometimes that it's the same answer twice. Sometimes it's 2 different answers like this one is. Okay. But the factors, when you get in this factored form, that's the parentheses stuff. That's where what we're going to use to solve some of these. We're going to learn some other methods tonight too, but this is the first method. Okay. So let's take a polynomial, a quadratic that is not factored yet, and let's take it through the steps of factoring. So x squared plus 8x equals 0. And I'm going to go over here on the side. I'm going to remind us of our rules of factoring that we did back in October. The first thing you always look for is what? Descending order. After it's in descending order, the greatest common factor is what we look for next. The third thing we do after we pulled out the greatest common factor, we look at what's left and we count terms. There are 4 terms. We'll group. 3 terms. X method. 2 terms. Differences of squares. Or it could be a sum or difference of cubes. It won't be tonight because we're dealing with quadratics, but it could be later on. So we'll put a star by that one because it's not going to use the time. Okay. All right. So with this one, is it in descending order? All right. So there's one thing to add to this. Make sure it's equal to 0 first. Before you even check descending order, make sure it's equal to 0. This one already is, but you need to check that. It's got to be equal to 0 to solve it by factoring. All right. So it's in descending order. Then we look for a GCF. Is there anything shared between x squared and 8x? They have x in common. It would leave x plus 8 in the parentheses. Will x plus 8 factor any further? No, it's a plain X. It's got an 8. That's done. Now, we have two factors there. X is a factor because it was the greatest common factor, right? So if it's called the greatest common factor, it's a factor, right? So X is equal to 0, and then the X plus 8 is equal to 0. I like it when you get X equals 0 because you don't have to do any work. You're done. That's an answer. But this one, you got to do a little bit of work. Subtract 8. X is equal to negative 8. Those are our two answers for this particular quadratic. You could take those answers one at a time and plug them back in for X in the original problem, and they check. 0 squared is 0 plus 8 times 0 is 0. If I plug in negative 8 squared is positive 64 plus 8 times negative 8 is negative 64. Positive 64 plus negative 64 is 0. So both of those are solutions to that particular quadratic. Okay, so factoring with the greatest common factor there. Good practice. Let's look at x squared plus 7x equals negative 12. Is that equal to 0? No. Let's get it equal to 0 by, it's the quickest way. Adding 12, yeah, that's the quickest way. When you're doing that, what you want to try to, one thing that can help it make it easier for you is make sure your x squared is positive. So if you ever have to move the x squared, if you're going to have to move it to make it a negative, then you probably don't want to move it. So here, that's a positive x squared already. Don't move it. If the x squared is positive, leave it where it's at. Move everything else, even if it's longer. Okay. And then, so there's going to be x squared plus 7x plus 12. Notice what order did I write that in? Descending order. So when you're moving that stuff, get ready to set it equal to 0. Put it in descending order. It's going to make it easier for you. Now, is there a GCF between all three terms? No. X and 7x. 12 doesn't have anything like those. So next thing is after GCF is count the terms. How many terms are there over here? 3. So that tells us to use the X method. Multiply to be 12. Add to be 7. 3 and 4. I can take the shortcut on this one. Why can I take a shortcut and go to x plus 3? Yeah, because there's a 1 in front of x squared. That allows me to go straight to those factors. X plus 3 and x plus 4. Those are my factors. The last thing that I do is set those factors equal to 0 and solve. X plus 3 equals 0. X plus 4 equals 0. Once you get to this step, the math shouldn't be hard. This is the easy part. The factoring is the hard part, no doubt. Negative 3 is an answer. Negative 4 is an answer. Take those back to the original, work them out. They do check. Those are the correct answers for that one. Okay. So factoring, this one we have the shortcut on it. Why did we have the shortcut again? Nothing. There's a 1 in front of the x squared, or nothing written there in front of the x squared. That's what allows us to do that shortcut. Well, D. 6x squared minus 3 is equal to negative 7x. Bless you. Okay. What do I need to do first? Move the 7x over to get it equal to what? 0. So if we're going to try to solve by factoring, getting it equal to 0 needs to be the first thing we do. And then we get it in descending order. So I'll put that 7x in the middle because it should be there for descending order. Now, GCF? No. How many terms? 3. So that's X method. What goes in the top of the X? Negative 18. 7 on the bottom. 6 times negative 3. 2 and I think it should be negative 2 and positive 9. To add to be a positive 7. So now, can I go straight to my factors? No. Remember, there's a number in front of x squared. That's what says, okay, you got to do grouping then. So we're going to put 6x squared. And it doesn't matter which one you put next, either plus 9x or minus 2x. It doesn't matter. I'm going to put the plus 9x first, because it really doesn't matter. And then I group the first two together. What's their GCF? 3x, leaving 2x plus 3. What do we pull out of the second two? They don't have anything in common, but what can always be in common? What will always go into 1? Yeah, 1, and because they're both minuses, I can make it a negative 1. That'll turn it into 2x plus 3 in the parentheses. That gives me my factors are 3x minus 1 and 2x plus 3. So there's the factored form. Then I take each of those and set them equal to 0. Solve. Add 1 and then divide by 3. 1/3. Well, this one, subtract 3. Divide by 2. So factoring, got to get it equal to 0, descending order, and then usually going to use the X method. Not always going to be using the X method, but usually. Okay. Example E. X squared minus 16 equals 0. Excuse me. In descending order. Is it equal to 0? Okay, so GCF. They don't have anything in common there. There's two terms with a minus sign in the middle. So I'm thinking that is a what? Difference of squares. What squared gets me x squared? What squared gives me 16? 4. My factors would then be what? X in the front, 4 in the back. One's a plus, one's a minus. That's a difference of squares. Set each factor equal to 0. And then solve it. So x, subtract 4. Be negative 4. Add 4. Be positive 4. Two solutions there. Now, when there's only an x squared in the problem, there's some other ways to solve it. Okay. The other way that you could solve that same problem would be using square roots. And this is a handy thing. It can speed the process up sometimes. And also works well when it's just a two-term polynomial that will not factor. So this one could have been solved using square roots. And the difference in solving using square roots and solving with factoring is that you don't want it. You don't need it equal to 0. Okay, you need to get x squared by itself. So I would add 16, and there we have x squared is equal to 16. Once you get there, to solve by square roots, you cannot have a plain x term. Make that clear. You cannot have a term that has a plain x if you're going to use square roots. Okay, you can only have x squared and then number. Okay, so here we would take the square root of both sides. The key is that when you take the square root of a number, you got to put the plus or minus in front of it, because the square root of 16 is not just 4, but it's positive 4 or negative 4. Okay, we take the square root of something squared, it takes the squared away. So that's x equals positive 4, and x equals negative 4. That one could be solved with either method, with factoring as a difference of squares, or with the square roots method. We're going to look at some others that we could do with square roots, but not that maybe doesn't work out as nicely. So, like maybe for example, this one. And we had something like this: x squared equals 18. For this one, I know I can use the square roots method because I don't have what? What's not in the problem? A plain x term. That's when you know you can use square roots, is when you've only got x squared and a number. That's when you know you can use square roots, okay? So for this one, we've got x squared, we've got a number, we've got x squared by itself. So that's where we can take the square root of both sides. So when I take the square root, I've got to remember to do plus or minus in front of the side with the number. So I have x equals plus or minus the square root of 18. And remember, last couple of weeks, we've simplified those square roots. Do a factor tree. Got a pair of 3's with the 2 left over. Plus or minus 3 square root of 2. So you got two answers. One's positive 3 radical 2. The other one's negative 3 radical 2. I'm fine with you writing the answer on labs and stuff, writing your answer like that. You're probably going to see it separated on Canvas or on your actual test. So when I look at this problem, what do I notice is missing? Plain x term. Anytime you look at these problems, before you even start them, you look at it and say, okay, does it have the x squared, a plain x, and a number? If the plain x is missing, then square roots is the way you want to solve it. It's the fastest way. So if the plain x is missing, square roots is the fastest way to solve it. Okay? So is x squared by itself yet? No. Let's get it that way. How do you get x squared by itself? Divide by 8. It's 56 divided by 8. 7. Okay. Then x squared's by itself now. So we undo the squaring of x by taking the square root of both sides, plus or minus on the side with a number. Don't forget your plus or minus. Left side is x squared, or square root of x squared is x. Right side, 7. Does it break down any? So we're just going to leave it plus or minus the square root of 7. So x equals positive square root of 7. X equals negative square root of 7. Square roots is an easier way, but it only works if the x term is missing.
You said 11, we could leave it at x equals plus or
Yes,
minus.
absolutely. Absolutely. Yes. Yeah. All right, let's look at maybe one that's a little bit different, but in the same kind of general vicinity of what we're doing here. X squared plus 4 is equal to 0. Does it have a plain x? No, so solving it by what is the easiest way? Square roots. So what do I need to do to be able to solve it by square roots? Subtract 4. Get x squared by itself. That's the idea. It'd be negative 4 over there. And then we take the square roots, plus or minus on the number side. What's the square root of negative 4? 2i. If there's a negative under the square root, that's where the I comes from. A negative under the square root is where the I comes from. Square root of 4 is 2. The I is because it was a negative 4 that we took the square root of. What do we need to do this one? Move the 24, so we're going to add it. Now what? Divide by negative 3. Be negative 8. Now what? Square root. Plus or minus on the side with the number. Now, does the square root of negative 8 break down any? Can I do a factor tree for 8? Yeah, it's 4 and 2, 2 and 2. There's a pair of 2s. So what does it turn into? Plus or minus 2. One more thing. Yeah. 2i and then the square root of 2. Plus or minus 2i, square root of 2. The I, again, comes from the negative underneath the square root. That's where that's going to come from. All right. So, what if it's like this? Let's make that a different number. Let's do 25 there. That way it's not the same number all over the place. When we talk about the 4, we mean that 4. So this one looks a little different. And it does have the plain x piece. But it's tied into some parentheses that are squared. Okay. No. Multiplying that out would work. We could do something with that, but it doesn't necessarily. It's not necessarily the best way of going about it. Anytime we see something like this, what you want to try to do is, okay, I've got something squared over here. I've got a squared piece equal to a number. I can undo the squaring of that piece by taking the what? Square root. So there's a faster way of getting there. So if I take the square root of both sides, don't forget the plus or minus on the side with the number, this square root eliminates that squared piece so that it's x plus 4 is equal to plus or minus, it's the square root of 25. All right, so we've got two problems to work here. We've got x plus 4 is equal to positive 5, and x plus 4 is equal to negative 5. Because it was the plus or minus. Okay, now solve each of those. You get two answers, 1 and negative 9. If you plugged each of those in individually to the original problem, 1 plus 4 is 5. 5 squared is 25. That works. If I plug in negative 9, negative 9 plus 4 is negative 5. Negative 5 squared is also 25. So both of those work as answers for that. So a squared piece, you can get rid of that squared by taking a square root. Makes it a lot easier. Even if that number on the other side isn't a nice number that has a nice square root. Maybe it's the number 24 over there. Not a nice number because it doesn't have a nice square root. I still get rid of this squared part by taking the square root of both sides. And then I can break down the square root of 24. 8 and 3, 4 and 2, 2 and 2. So there's a pair of 2's and then a 6 left over. And then I can get x by itself by doing what? Adding 3. 3 plus or minus 2 radical 6. You got two answers there. We don't go ahead and work those out because they're not like terms. On this other one here, we went ahead and worked them out because 4 and 5 they're not regular plain numbers, don't have the radical involved there. So using that square roots property, yeah, man, it's pretty awesome, quick way of solving those. Let's look at this one. Maybe you got x. Let's make it 2x minus 1 squared is equal to negative negative 12. You got a squared piece and it's equal to a number. Anytime you got a squared piece and it's equal to a number, you can get rid of the squared piece by taking the square root of both sides. So that's the clue that you're looking for. Well, they call that in English. Context clues, I think is what they call that in English class. Look at the problem, see what's going on with it, and use what it's telling you to get the best way to solve that problem. And then simplify that square root. 6 and 2, 3 and 2, there's a pair of 2's. So what all comes out of that square root? 2i radical 3. And then we got 2x minus 1. Let's get x by itself, so you add 1. This 1 is not like this other stuff because this 1 doesn't have an I or a radical. So it's 2x is equal to 1 plus or minus 2i radical 3. And the last step would be divide everybody by 2. That's 1/2 plus or minus. Does 2 go into 2? Yeah, so it's I radical 3. And there's our two answers out of that. This 2 and this 2 cancel one another out. That's what's happening there. It's those that cancel. There's another way to solve that's called completing the square, which allows you to take any problem and turn it into a problem that you can solve by square roots. It is a valid method, but there's about 7 steps to do every one of them. And I don't think it's worth doing it that way, because we have another way that's called the quadratic formula. Quadratic formula it goes back to the form that it was in when we were factoring. You got the ax squared plus bx plus c is equal to 0. So it's back to that everything's equal to 0 idea. And the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And if you want to see somebody derive that formula from that standard form, you can YouTube that. It's out there. But what this will do is it'll find the solutions to any quadratic that can be, you get set equal to 0. Even the ones we solved by square roots, even the ones we factored, especially the ones that won't factor. That's what its purpose was. It was created because we had some that didn't factor. Okay. In my Algebra 1 class in high school, we sing this song. It's a song. I don't know if you know this is song lyrics, but it is. And we usually do it to the tune of Row, Row, Row Your Boat. It works really good. It helps you memorize it, because I'm horrible at memorizing things. But if you put it to the tune of music, I'm pretty good at memorizing those things. So it's x equals negative b plus or minus radical b squared minus 4ac divided by 2a. So if you could sing that over and over, it helps you memorize that formula so that you don't have to constantly keep looking it back up. So you can also do it to the tune of the theme to Gilligan's Island. Does anybody know that theme? Dun, 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 dun. I had a professor in college who put everything to that tune, so it was useless. Because everything we had to memorize, he'd sing it to that tune because it could, and so it just jumbled it all together, and you just had to come up with your own songs. But I've had students that do it to other tunes in high school, and they're pretty creative with it. But memorizing that formula, having it there is something that will be good for you to do, because it's very useful, because it works no matter what. So even if you can't factor it, if you're struggling with factoring, quadratic formula works. If you're good at factoring, great. If you got a problem that won't factor, quadratic formula works. If you're good at square roots, great. If you're not good at square roots, get it equal to 0 and use quadratic formula. It works. Okay. This one works all the time. It's like the universal tool of quadratic equations. It's the bigger hammer. Okay. For those of you that work on things. If it doesn't work, get a bigger hammer. It usually will work then. Okay. So let's look at a problem or two with quadratic formula and get a little practice working with it. All right. So here we have x squared minus 4x is equal to negative 2. If we're going to solve that quadratic, whether I'm going to use factoring or quadratic formula, I still have to get it equal to what? 0. So the work is not any different here. And in my train of thought, what I usually do is I say, okay, do I know anything that multiplies to be 2 and adds to be negative 4? If nothing jumps out to my head really fast, I say, okay, quadratic formula time. And I go, okay, what's A, what's B, and what's C? What's A for this particular problem here? Yeah, what's in front of x squared? 1. B is what's in front of x. It's a negative 4. C, this number here, positive 2. Okay. I have that list. Then I go to my quadratic formula and I plug that stuff in. X equals negative b, so that's the opposite of b, would be positive 4 plus or minus negative 4 squared minus 4 times a times c. Guys, this 4 right here is always there. That 4 is always there. Okay. Over 2 times A on the bottom. Then all I got to do is work that out. It's going to give me my answers. That's the beauty of a formula. 4 squared is 16. Minus 4 times 1 is 4 times 2 is 8. 2 times 1 is 2. 4 plus or minus the square root of 8 over 2. Square root of 8. 4 and 2. 2 and 2. So a pair of 2's. So we have 4 plus or minus 2. Square root of 2. All that divided by 2. What you do when you get to this step, you look at the numbers that are on the outside of the radical, or the outside of the square root, and you say, are they all divisible by something? In this case, they're all divisible by what? 2. Divide them all by that. So 4 divided by 2 is 2. 2 divided by 2 is 1. So that's 1 radical 2. And then on the bottom, 2 divided by 2 is 1. So technically this is over 1, but you don't ever write that. You just leave it there. And there you have found your 2 solutions to that quadratic using the quadratic formula instead of factoring. Factoring would not even work for this one. Quadratic formula was your only option. Well, not your only option, but your best option. Okay. Let's do this. X squared minus 3x plus 5 is equal to 15. What do we need to do first? Get it equal to 0, so move the 15. It's going to be x squared minus 3x minus 10. And then, thinking for things that multiply to be negative 10 and add to be negative 3. Maybe that works. Maybe it doesn't. Maybe it jumps out to you that it's negative 5 and positive 2. That's wonderful if it does. What if it doesn't? Okay, quadratic formula still works. I'm going to use that. A is 1, B is negative 3, C is negative 10. So when you do quadratic formula, x equals negative b plus or minus radical b squared minus 4ac. Can't write as fast as I sing. Divided by 2a. And then we're just going to work this out. 3 plus or minus. Negative 3 squared is 9. Negative 4 times 1 is negative 4. Negative 4 times negative 10 would be positive 40. And that works out real nice because I get 3 plus or minus the square root of 49. And we know the square root of 49? Yeah. 3 plus or minus 7 divided by 2. Well, can I add 3 and 7? They're regular numbers, right? They're like terms. So I could do 3 plus 7 divided by 2. That'd be 10 over 2, which is 5. And I can do 3 minus 7 over 2, which is negative 4 over 2, which is negative 2. My solutions are 5 and negative 2 using quadratic formula. If I had factored that sucker, been x minus 5 and x plus 2, my factors set equal to 0, get you the same answers. Factoring works for this one, but quadratic formula works too. You could solve every stinking one of these with quadratic formula. It's a pretty powerful tool. Factoring's nice and it's fast. Square roots is nice and it's fast. But quadratic formula works every time. So sometimes it's better to have something that works every time than it is to have something that works fast. Okay. All right. Let's look at this one. Two x squared minus x plus 3 equals -1. Throw a negative in there. Make it fun. What do we do first? Get it equal to 0, so we're going to add 1. So it's 2x squared minus x plus 4 equals 0. Given the choice, I usually, if there's a number in front of x squared and they didn't tell me I had to factor it, and they just said solve it, I usually don't even try to factor it. I'll just go, I'm doing the quadratic formula, because I got to do grouping anyway if I factor this, and by the time I've done all that grouping, I could have done quadratic formula and had the answers. So that's usually what I try to do here. I know there's nothing multiplies by 8 that has to be -1 anyway, but anyway. So it's always helpful to get that A, B, and C list, whether you get it in your head or you write it down. I always just write it down when we're doing notes because we need to refer to those things. A is what? B, -1. C, 4. All right, so those are your A, B, and C. Whether you can put that list down on paper or you just have that in your head, it doesn't matter. And then when you go to your formula, negative B, the opposite of -1 is +1. B squared, so -1 squared minus 4 times A times C over 2 times A. And A is 2 this time. 1 plus or minus the square root of 1 minus 32 over 4. Square root of -31. Can that simplify any? I disagree. That right there. It's a negative inside, so what will always come out? An I. The number 31's prime, so it won't do anything. Yeah, I knew that's what you meant, but there we have our solutions to that quadratic. Okay. This stuff underneath the square root, the b squared minus 4ac, it's the discriminant. And if something is a discriminant, that means it discriminates. What it does is discriminates what kind of answers you have. Okay? If b squared minus 4ac is greater than 0, what kind of number is it? Is it positive, negative, or negative? It's positive, right? So if it's greater than 0, it's positive. If that under the square root is a positive, you're going to have two real solutions. You can get real numbers. If b squared minus 4ac is equal to 0, you're only going to get one real solution. If b squared minus 4ac is less than 0, what kind of number is it? Negative. That's when you have two complex numbers as your solutions. Two complex numbers. And the last example we had the complex numbers because what was underneath the radical? A negative 31. So that's a negative discriminant. So the discriminant being negative tells us there's two complex solutions. I've seen this question on the final every year. It'll just say, what kind of solutions does this problem have? If you can just do the discriminant, you can get the answer to that. You could go ahead and find the answers and also get it correct, but you could save yourself a little bit of time by just doing the discriminant to find that. So methods for solving quadratics are factoring, square roots, or quadratic formula. Factoring works great sometimes. Square roots is great sometimes. Quadratic formula always works. Okay, keep that in mind. All right, let's look at some application problems of quadratics. Poster. It's always funny to read that word, a poster. My brain automatically now jumps to a social media poster instead of a piece of paper that you put things on when you were a kid in school, because we don't do that stuff anymore. But a poster has an area. This is not a social media poster. This is a poster with paper. Has an area of 216 square inches. The width is 6 less than the length. Find the dimensions. All right. So application of this. Now, a lot of times I had a professor in differential equations class, and he was very generous to us. He said, if you can draw a good picture, it can help you work the problem. And what he meant was, if you can draw a good picture, I'll give you some credit on your test when you don't do the problem anyway right. So drawing a picture does help, though. It did really help on a lot of the problems. So we're going to draw a poster. Posters are normally rectangular. Okay. We know that this has an area of 216 inches square, or square inches. And it has a length and a width. Okay. Do we know the length? So we're going to call it X. Do we know anything about the width? 6 inches, I meant to put inches there, less than the length. So if the length is X, the width, X minus 6. There you go. And then they told us something about area, but we got to have a little bit of general knowledge about rectangles. How do you find the area of a rectangle? Length times width. Okay. So if we know that the area is 216 square inches, we know the length is X and the width is X minus 6. We now have a quadratic equation that we can solve. So I'm going to go ahead and multiply out the X squared minus 6X, still the 216 there. And if I'm going to solve a quadratic, what do I need it equal to? 0. So I'm going to move the 216. Got a couple of options here. I could factor it, maybe. But I don't know. 216 is a pretty big number. So that means there's probably a lot of really big, a lot of options for what can multiply to be 216 and add to be negative 6. So we could end up spending a lot of time looking for those numbers. It's going to be the last one we look at, right? But so I'm just going to do quadratic formula. X equals negative b plus or minus 4ac divided by 2a. That discriminant should be a positive number here. If it's not, we're in trouble. Because this is a real poster that we've drawn. It should have real solutions. So if something were to happen here and you get a negative underneath that radical, you probably plugged something in wrong on these application problems. 6 plus or minus the square root of 36 plus 4 times 216 be 800, and 4 times 16 be 64. 864. 36 and 864. That works out nice because that's 900. And 900 has a nice square root. What's the square root of 900? You may know. 30. 6 plus or minus 30 divided by 2. So we got two answers. 6 plus 30 divided by 2. 6 minus 30 divided by 2. What's 6 plus 30 divided by 2?
Wait, no.
36 divided by 2. Try again. 18. And then 6 minus 30 would be negative 24 over 2, which is negative 12. Can the length of that thing be negative? No. That one's out then. So X is 18 inches. X represents what for our poster? Length or width? X is the length. Remember we drew our poster here? X is the length. And the width spell length. L-E-N. 18 inches. Width would be 18 minus 6. -6 would be 12, positive 12 inches. Those numbers won't always match. They do a lot, but they don't always. Let's set up the numbers that are involved. We get our dimensions there for our, and using a quadratic to build that. Not really too terrible. Let's do a consecutive integers problem. Find two consecutive integers whose product is 110. Okay, so a couple of different ways to do this. One way would be just be logically thinking and guessing and checking, which could work, and depending on the numbers and the number that their product is, you know, this one's pretty easy. It's 10 and 11 because 110, 10 times 11. But what if it's like 346? Yeah, that's a little bit more difficult. So setting up an equation is a more general way of doing this. So to set up an equation for two consecutive integers, your integers, the first one we're going to call x, and then the next one to be consecutive would be x plus 1. Because if the first integer was 10, the next consecutive one would be 11, so you'd go 10 plus 1, right? Now we got a problem that's, doggone it, it's just like the area problem that we had. Multiply it out. Subtract it over. And then I could run quadratic formula. -1 plus or minus 1 squared minus 4 times 1 times -110 divided by 2 times 1. Be -1 plus or minus 1 plus 440 over 2. And something tells me that 441 has a nice square root. So I would check that with the calculator. The square root of 441. I hope it's 21. Is that correct? Did it? So you get x equals -1 plus 21 over 2. -1 minus 21 over 2. That's 20 over 2. 10. -22 over 2. -11. That's out. So that's not consecutive to 10. So, but there's two different, since this is not a distance problem, you actually can keep that. Two different sets of integers this could be. You could have the integers being 10 and 11, or they could be -11 and -10. You get both sets there, which you could miss if you're doing this by the guess and check method instead of setting up an equation. Guess and check. Sometimes you lose the negative side of things because -11 times -10 is still 110 positive, and they're still consecutive. Okay. All right, 2 more sections. Fun stuff. All right, so we're going to look at some quadratic inequalities next, and then we'll end the night with some graphing or some pieces of graphs. We won't actually we'll graph it with the calculator, but we'll look at some pieces that we need to know about with quadratics last. Okay, so quadratic inequalities. So this is section 1.7. I'll get out of here pretty early tonight, I think. Maybe. That last section is going to be a doozy. But all right, quadratic inequalities. All right, so let's start with just an example. There's really no better way to do this than show you some examples. All right. So we got a quadratic, and instead of having it equal to 0, we've got an inequality symbol here. Okay. Most of the work we're going to do is exactly the same as if it were an equal sign until we get to finding until we get to telling what our answers are. Okay. So all of the work for finding the solutions to this is the same as it was with an equation. All right. So options are factoring or quadratic formula. Both of those work well. This one would factor pretty easily. The -12 and -1, that'd be -4 and 3. So you could have x minus 4, x plus 3, and then it's less than 0. What you want to do there is you want to set x minus 4 equal to 0, x plus 3 equal to 0, just like you would if it were an equation. You get x equals 4, x equals -3. What you're doing then is you're setting up a number line interval. This is where it's different. We got those numbers, then we set up this number line interval. -3 is here, +4 is here. That's in order left to right. Smallest number on the left, biggest number on the right. Okay. On that interval, you're going to put open circles on those. The reason they're open circles is because it's just a regular less than symbol. If it had an equal to mark, you'd fill in the circles. You'd fill them in saying that -3 counts as an answer. This with the open circle on it says -3 doesn't count as an answer, but it's where answers could start or stop. Okay, so we have 1, 2, 3 areas on this number line. We have the numbers that are less than -3. We got the numbers that are between -3 and 4, and then we got the numbers that are greater than 4. 3 different areas. We've got to check 3 different numbers. from those areas in the original inequality, okay, to decide if it's true or false. So you pick a value to test. So I need a number that's less than -3. -5 is a good one. -4 would have worked. You could even use -10. Doesn't matter. Just pick a number that's less than -3 and test it in the inequality. So -5 squared minus -5 minus 12. Is that less than 0? That's what we're wanting to know. So that's 25 plus 5 minus 12. What's 25 plus 5? It's 30. 30 minus 12. 30 minus 12 would be 18, wouldn't it? Is 18 less than 0? No. So everything in this area is false, because this is false. Okay? Now I need to check a number that's in between -3 and 4. What's the easiest number between -3 and 4? 0. I'm going to pick 0 to check. So 0 squared minus 0 minus 12. The question is that less than 0? So that's 0 minus 0 is 0 minus 12 would be -12. Is -12 less than 0? That's true. So this whole area has got to be true, because that one test point worked and got true. The rest of that area between -3 and 4 is true. Let's check this other area. We need a number bigger than 4. I'd say 5. It's a good one to plug in. 5 squared minus 5 minus 12. Is that less than 0? 25 minus 5 is 20. 20 minus 12 is 8. Is 8 less than 0? No, that's false. So your solution set is only the numbers between -3 and 4. Okay? How do we write that in interval notation? That's how we write it. From -3, starting at -3, going up to 4, but not including those, because they had open circles on it. The inequality symbol did not have an equal to mark, so you can't include it. If the inequality symbol has an equal to mark, then you'll use a square bracket on the edge, because it's interval notation. All right, let's do another. It is possible, guys, to have more than one area that's true or false. It won't always just be one area. It's possible to have more than one. So if I can make another one up that does that. 2x squared plus 5x, and let's do greater than or equal to 12. So we want to solve this thing just like if it were an equation. So I would move the 12 to get it equal to 0. Doesn't matter if you put the inequality symbol there, you can. It doesn't matter. But we're going to solve that. I'm going to use quadratic formula. And then simplify it to see if I can get my numbers. So that'd be -5 plus or minus 25. -4 times 2 is -8 times -12 would be positive 96. 25 plus 96. 121, which is a nice number because the square root of 121 is 11. So I get x equals negative 5 plus 11 over 4. X equals negative 5 minus 11 over 4. So negative 5 plus 11 would be positive 6 over 4, which is 3 over 2. And negative 16 over 4, which is negative 4. Okay. Those are the numbers that I put on my number line to test around. Okay. Put some space here. Which one's smallest? Negative 4, so it goes on the left. And then 3 over 2 over here. Filled in dot on the negative 4, because that means it's included. It's included because the inequality symbol has what on it? The equal to mark. 3 over 2 is also included because the inequality has an equal to mark. All right, now pick a number to test in the leftmost region. Negative 5 is a good one. So that'd be 2 times negative 5 squared plus 5 times negative 5. And I can go back to the original or to this one right here. I'm going to go to this one right here because it's pretty easy to test if something's greater than or equal to 0. That's easier than checking 12. Not that checking 12 is that difficult, but I'm a little quicker at that. Okay. Put the calculator up there. So 5 squared is 25 times 2 is 50. Minus 25 is 25. 25 minus 12 is 13. Is 13 greater than 0? Yeah, so this area is true. I'm going to pick a number between negative 4 and 3 over 2. 0 is a good one because it's easy. That's 0 minus 12 is negative 12. Is negative 12 greater than or equal to 0? No, so this area is false. Then I'm going to pick a number bigger than 3 over 2. One's not big enough. 2 is the next biggest. Is a good big one. So 2 plugged in there. So 2 times 2 squared minus 5 times 2 minus 12. Is that greater than or equal to 0? So that'd be 4, 8 minus 10 is negative 2. Minus 12 is negative 14. Is negative 14. Hold on. Didn't do that right. 2 squared is 4 times 2 is 8. Minus 10 is negative 2. Yeah, that's right. And then negative 2 minus 12 is negative 14. Is negative 14 greater than 0? No. So it's false in this area too. So our only solutions are the numbers that are less than or equal to negative 4. So our solution set start at negative infinity, come up to negative 4. It's always a parenthesis on the negative infinity. Because negative 4 is included, it's a bracket. All right. There's our solution set. Solve them like we did in the first section. And then set up the number line and test points, picking numbers in each little section, testing them. And then your solution sets are based on that number line, what's true and what's false. All right. Last section of the night is 7:15. All right. So we're going to be looking at some pieces of graphing. We're going to do the main graph on our graphing calculator. But we're going to be looking at some graphing for quadratic functions. Okay. Instead of having it set equal to 0 when you start, they're going to give you an equation either with f of x equals ax squared plus bx plus c, or instead of f of x, they might have y there. It's the same thing. F of x and y are the same thing. Okay. Now, the graphs that we're going to draw could look like this, or they could look like this. Okay. The direction that the thing opens is based on A. If A is greater than 0, what kind of number is it? Positive. If A is positive, the graph's going to look like that, opening up. If you're a positive person, you're smiling a lot, the corners of your mouth goes up, right? That's the way I've remembered it since I was a teenager. So, and if you're a negative person, A is less than 0. Most negative people I know frown a lot, right? Some people just frown a lot anyway. They're not negative people. They just don't smile a lot. So, but negative, pointing down, opening down, positive, opening up. Okay? All based on what A is and nothing else. A controls that. It's in front of the x squared. X squared is the most powerful part of that equation. And A being positive or negative sets the tone for the graph. Okay? All right, so knowing that, which way it opens, up or down, is based on A. Okay? And then another thing that we will find is called an axis of symmetry. And it has a formula. X equals negative B divided by 2A. And yes, that's the same. It's part of the quadratic formula. It's involved there. The quadratic formula had that negative B plus or minus radical stuff, but it was all over 2A. This is directly related to that. Okay, that axis of symmetry in the graph, your graphing calculator won't show you this, but just know that the axis of symmetry is this line that goes down the center of that quadratic. If the axis of symmetry, if you could pick this screen up and fold that graph along that dotted line, the symmetry part means it match up side to side. But axis of symmetry always goes through the middle of the graph. Okay, so and when you look at the graph and look at your number you got for axis of symmetry, it should be around the center of the graph as far as the x value goes. Okay, from the axis of symmetry, we can then find the vertex. The vertex is an ordered pair. The x value is the same number that you got for axis of symmetry. It's negative b over 2a. The y value is take that number and plug it into the problem and get y. Work it out. Function value. So it's an ordered pair, x comma y. Once you get the axis of symmetry, you got half of the vertex. The vertex is this point right at the base or at the top of the quadratic. Here, highest point's a vertex, lowest point is a vertex. That's what that point is. That's the ordered pair we're finding, is what that point is. The axis of symmetry will always go through that point. Always. So if you're trying to, like maybe you got a multiple choice type question on the final exam, and you know what the vertex is of the equation you got, and you see a graph and it's not, the graph A doesn't have that as the vertex, well, you know it's out, because the graph has got to go through that. You know the axis of symmetry has to go through that. based on everything that works right and makes the world spin in the right way mathematically. Okay. We're also going to find the X intercepts and the Y-intercept. The Y-intercept is the easiest one of everything we do. It's just 0, comma, C. It's an ordered pair. Whatever C is in the equation, the number that's hanging out here on the end, that's your Y-intercept. If it's in standard form, that's the Y-intercept. Always, forever. Okay. The X-intercepts is exactly what we've been doing all night. It's where you take the problem and set it equal to 0 and solve it. That's how you find X-intercepts. And we'll do that as we go through these. Okay. All right. Now, let's look at an example or 3, 4, example or 4 of this, and get the idea. So the first example, f of x equals x squared plus 6x plus 8. Okay. The first thing I want to find is which way it opens. Without even graphing it, I should be able to tell that. What's A in this problem? What kind of one? So which way is it going to open? Up. Okay. Now, let's find that axis of symmetry. Negative b divided by 2a is the formula. Negative b would be negative 6. 2 times a would be 2 times 1. So that'd be negative 6 divided by 2, which is negative 3. Or axis of symmetry is x equals negative 3. And it is an equation because it's a line. Okay, so it's x equals. Axes of symmetry are for quadratics are x equals, or the quadratics we're dealing with, because we're dealing with functions of x. Okay. We get half of the vertex for free because it's always going to match the axis of symmetry. The x value is going to be negative 3. We have to find the y value. So we need to take negative 3 and put it in the place of x in the problem. And work that out. Whether we use a calculator or whatever to get there, that's what we're going to do. So this is where maybe I start employing the calculator a little bit and the graphing capability of the graphing calculator. Okay. So got my graphing calculator. I'm hitting y equals. And I want to check to make sure things are going to graph the right way. I'm going to get rid of anything that I've got in my y equals stuff. You know, scroll down, make sure you didn't have anything crazy in the y in all 10 of them. Mine are all empty, so that means I'm good. There is something crazy going on my screen that I need to take care of. Up there in the top, notice how that plot 1 is darkened in. If that's darkened in, you need to turn it off. If for whatever reason your plot is darkened in, turn it off. So you just arrow up to it, the one that's turned on, hit enter, and notice how it's not solid anymore. It's blinking, and it's not there. So turn those off. And then I'm going to type in the equation. X squared plus 6x plus 8. So x is right beside the green alpha button right here. It's highlighted in red right now. Then squared right there, highlighted in red right now. Plus 6x. And then plus 8. And I'm going to hit graph. And my screen is not in the right place. I don't even see anything. So to get my screen in the right place, I'm going to hit zoom. That button hit that right there in the center, right underneath the screen. Zoom, and then the number 6 to get the standard window. And there I have a nice picture of a quadratic. Now, is my quadratic opening up? We knew it would, right? Because A was positive 1. We knew it was positive, so it's opening up. And then we know that the axis of symmetry is x equals -3, which would be a line that goes through right here. The vertex, the x value of the vertex is -3. Where's the lowest point on this graph? Right here. What does it look like the x value there is? -1, -2. Hey, there's -3. That's where the x value is. So I think I've got the graph done correctly. I think my answers on my paper are correct. Now, I need to know the y value for that point. Here's where the calculator can help you do that. One way would be just type in the problem on the regular calculator screen and hit enter. With the graph, you can actually hit the trace button. So up there, highlighted red right underneath the screen, second one from the left, from the right, hit trace, and then type in the x value you want to work out. I want to work out -3. So I type in -3 and hit enter. Hit enter. Hey, there's my y value. -1. That's nice and handy. Saves you a little bit of headache and work and arithmetic out of that. But that works wonderfully. So, wrong page. There we go. That's -1. So the y value is -1. So there's which way it opens. My axis of symmetry, we got that from the little formula, -b/2a. And my vertex is -3, -1. When I look at my graph, is that little x that it put on there, is that right at the lowest point? Yeah, it looks like it is. You're just kind of eyeballing things here. And it looks like it's the right spot. And it is. Okay? Now, the hard part are the intercepts. The easy one is the y-intercept. What's the y-intercept? 8, 0, 8. If I look at my graph, y-axis, it's crossing it right there. What's that number? 1, 2, 3, 4, 5, 6, 7, 8. No, not a coincidence. There's no coincidence in math. It just happened to be that way. It is that. All right. So, got the right y-intercept. Let's get the x-intercepts. This is the hard part. Take the problem, set it equal to 0. Either factor it, quadratic formula, square roots. Whichever one works. Factoring works for this one. X plus 4, x plus 2. Set those equal to 0. And you get those. So the x-intercepts are at -4, 0, and -2, 0. Go back and look at the graph. And look where that thing is crossing the x-axis. What number is that? -4. What number is that? Not a coincidence again. If it's got x-intercepts, you should be able to see them. Now, if the x-intercept is square root of 2, you're not going to be able to get exactly that by looking at the graph. You're going to have to do the algebra to get there. But if you get the answers as plus or minus the square root of 2 as the x-intercepts, you should be able to look at your graph and say, well, the square root of 2 is what number? It's about 1.2. Is it crossing the x-axis close to that? So you can get your x-intercepts using quadratic formula and all that same way we've done it all night, but it should match up with what your graph's doing if you've got real answers for x-intercepts. If you have complex solutions, then it won't cross the x-axis at all. Okay? Complex solutions for x-intercepts means it doesn't cross the x-axis. Okay, that's maybe a generalization that you need to think about there. All right, let's look at another one that maybe it's not as perfect as that one is. G of x, x squared minus 4x minus 2. Which way is this thing open? Y. Positive in front of x squared. Positive 1 in front of x squared. Okay.
The problems that are on the book, are you going to write it on there?
I will. They'll be on the video. Yeah. Yes, sir. All right. So we know it's going to open up. Axis of symmetry. X equals negative b over 2 times a. So it'll be 4 over 2 is 2. So x equals 2. We know the vertex. We get that for free because we got the axis of symmetry. And then plug that into the original problem to get the y value. Whether you do that with the calculator and the graph and the trace button or the old-fashioned way, I don't care. But you got to be able to do it. So be 4 minus 8, which is negative 4 minus 2 is negative 6. If you did that with the calculator, I'm just showing you some skills with the graphing calculator. X squared minus 4x minus 2. My graph. It's opening up. That makes me feel better about my answer there. If I hit trace and type in a 2 at the y value there, does it look like it's at the lowest point? Yeah. So that I know that's my vertex then. Okay. My X intercepts, which is the next place we're going, they're not on nice numbers. So guessing at them would be one way of getting there, but you're not going to get it right, most likely, because you can't eyeball the difference in 0.45 and 0.46. I don't know anybody that's got an eye that calibrating. Okay, so actually doing the algebra to get there is what you're going to have to do. Y-intercept we probably can get. What is the Y-intercept here? Where's it crossing the y-axis there? Negative 2. What's C in the problem that we got here? Negative 2. So the Y-intercept, yeah, that's easily doable. 0, negative 2. The X-intercepts, we're taking that problem, x squared minus 4x minus 2, and setting it equal to 0. I don't know anything that multiplies to be negative 2. It has to be negative 4, so I'm going to go to quadratic formula. Negative 4 squared minus 4 times AC divided by 2A. It'll be 4 plus or minus 16 plus 8 over 2. 4 plus or minus the square root of 24. Which the square root of 24 is not a nice number, so we got to break it down. 8 and 3, 4 and 2, 2 and 2, so it's a pair of 2's. 4 plus or minus 2 radical 6 over 2. That'd be 4 plus, or 4, 2, and 2 are all divisible by 2, so I'm going to divide them all by 2. 2 plus the square root of 6, 2 minus the square root of 6. 2 plus the square root of 6 is 2 plus the square root of 6. Whoops. Second square root of 6 plus 2. 4.45. And then 2 minus the square root of 6. 2 minus the square root of 6. Negative 0.45. So my x-intercepts are at negative 0.45, 0, and 4.45, 0. About. Those are rounded values. On my graphing calculator, when I look at that graph, if I hit trace and then do 2 plus the square root of 6, Look at that. Give me y equals 0. Not a coincidence. And if I do 2 minus the square root of 6, gave me 0 for the y. Not a coincidence that that's happening. Okay, that is not coincidental. That stuff happens on purpose. Okay, so if it's in standard form, that's the way we're going to find all that information. All right. Now let's look at a different form that they may give us the function in. Okay, my voice will hold out just a few more minutes. Vertex form is really great for finding the vertex. It's not so great for much else. Okay, so vertex form, really great. Vertex form looks like this. That A is the same A that we've had all night. Still A. And then we have parentheses, x minus h, close the parentheses, squared, and then plus k. All right, now, which way it opens? If A is positive, it's up. If A is negative, it's down. That doesn't change at all. A is A the whole night. It hasn't changed. It doesn't change what it does. Okay. All right. Now, the vertex form, getting the axis of symmetry is much easier. If it's in this form, the shortcut is it's just x equals h. Whatever's here is what our axis of symmetry is. And then our vertex is h comma k. And that k is that guy right there. Without having to calculate one thing, we've got those first three things because it was in vertex form. If it's in standard form, we got to do the calculations for those things. But if it's in vertex form, hey, that's not so bad. I get them for, by just knowing where things are. Knowing that the axis of symmetry will always be in here. And that the vertex will always have that same number. And then whatever's out here is the y value for the vertex. Okay. Now, when it comes to finding the Y-intercept, it's not real nice for that. Not good for finding the Y-intercept. But to find the Y-intercept, plug in a 0 for x and work it out. And that math is doable. The X-intercepts, take that thing and set it equal to 0. And I'm going to write square roots. Because that's the way we want to solve it, if it's in vertex form to start with. Okay. So let's look at one that was in vertex form to start with. Example C. Here's our function. F of x is equal to 5, parentheses x minus 6, squared, minus 20. Okay. Which way is that thing open? What's A? 5. Positive or negative? Positive, so it's going to open up. If it were negative, it'll open down. Okay. Abbreviate here. I'm trying to write that out. Axis of symmetry. Remember, our form has x minus h squared. So our axis of symmetry is x equals h. So this is going to be x equals 6. I guess the best way to think about that is always take the opposite of whatever's in the parentheses. If it's a minus 6, it's going to be positive 6. If it were a plus 6, it'd be negative 6. So it's always the opposite of what's happening in the parentheses for the axis of symmetry. Then the vertex 36. And then what's the K that's hanging out on the outside? Negative 20. That's our vertex. And we're going to find the Y-intercept. This one's not as nice. You can't just look at it and get the Y-intercept. You got to work a little bit for it. But we didn't have to work at all for the other three things. So that I'm okay with working a little bit to get the Y-intercept. So I'm going to plug in a 0 for X. 0 minus 6 squared minus 20. So that'd be 5 times negative 6 squared. That'd be 36 times 5. Be 150 plus 30. 180 times 20. 160. So the Y-intercept is at 0, 160. This one wouldn't be a good one to look at our graph on the calculator and get the Y-intercept either, because 160, that's a stinking huge graph we'd have to look at. Okay. Now the X-intercepts, last thing we got to find. We're going to take that 5 parentheses X minus 6 squared minus 20 and set it equal to 0. To find the X-intercepts, square roots is the quickest way to solve that. Okay. And to solve it by square roots, you need to get the squared part by itself. What part of this thing is squared? That stuff. We get that guy by himself, then we can take the square root and then get X by itself. Okay? So I'm going to move the 20 first by addition. That's 5 parentheses X minus 6 squared is equal to 20. How do I get rid of that 5? Divide. 1 by 2. It's a 5. 20 divided by 5 is 4. That's nice, because I know the next thing I'm going to do is what? Get rid of the squared by taking the square root. Oh, man. Square root of 4, 2. But not just 2, plus or minus 2. So we got X minus 6 equals positive 2 and negative 2. So X minus 6 equals 2. X minus 6 equals negative 2. And solve those. X equals 8. And X equals 4. 8, 0, 4, 0. Those are our X-intercepts. Using square roots to get there. That vertex form, really handy for solving some parts of this. Not as nice for Y-intercept and X-intercepts, but square roots makes that a little bit easier. Okay. All right. So that gets us through the quadratic things. Here's the thing about that, though. We've still got to be able to do the quadratic things when we start doing the larger polynomials later in the next 2 weeks. Okay. So being able to do these quadratics is going to be important, because your goal when you do higher degree polynomials is to break them down until you get a quadratic. Because we got a lot of tools tonight for using with quadratics. We got factoring, we got square roots, we got quadratic formula. Quadratic formula being the strongest of the tools that we had. When we get to higher degree polynomials, starting a little bit of that next week, we got to break them down until we get them to a quadratic, and then we've got tools to do it. So we've got to learn some tools in the next couple of weeks to do those. But problems that you could look at for this week: page 111, 1 through 69, 83 through 91, page 118, 1 through 49, page 146, 39 through 51. Not a whole lot of problems in that set that could help. And then page 293, 1 through 83. Obviously, I'm not asking you to do all those. I'm not taking up any of those, but that would help get you prepared for your Canvas quiz that will be available this week, and get you ready for that. So I should have your Canvas quiz up on tomorrow, and for you to be able to do between now and Monday of next week. Also, don't forget, think about what you want to do as far as that Monday after Thanksgiving. If you want to go ahead and get exam 4 out of the way, or you'd rather push exam 4 back to the following week and review for the final more on your own than with me. So keep that in mind. Be very safe going home. I know it's been pouring down rain since we've been in here, so be careful going home, please. Turn around, don't drown, as they say.